Hey, hello everyone. Today we are going to solve this problem of the day from GHG, non-repeating numbers. So we have been given an array of 2 into n plus 2 positive numbers, out of which 2 into n numbers exist in pairs, whereas the other two numbers occur exactly once and are distinct. So basically there is an array of some size and there are n elements that are repeating. So basically 1, 1, 2, 2. These two numbers are repeating because the value n is equal to 2, and the other two values are 3 and 4 that occur only once and are non-repeating. So we have to return these two numbers in sorted way. So here also, since the value of n is 1, so this number 2 is being repeated and 1 and 3 are occurring once, and we have to return 1 and 3. Okay, fine. So now the time complexity expected here is on. That means that we cannot sort it. That would be a brute force approach. And also the space complexity is 1, so we also cannot make use of any map. So this brings us to the only possible solution, and that is bit magic. So bit magic, here we will make use of the very powerful operator, that is XOR. Sorry, yeah, fine. So we all know that XOR is given by operator. This is the operator of XOR. So what XOR does is for 0, 0 the output is 1, then for 0 and 1 it is a 1. Basically this is 0, then fine, right, then again for 1 and 0 it will be 1, and finally for 1 and 1 it is 0. So basically XOR, what XOR does is, if the both of the bits are different, then it will return 1, and if they are same, then it returns 0. So one very good property, basic property of this is, if we XOR any number with itself, then we get the number 0. So basically all the bits will be the same in both of the number, and since the same bits result in 0, so the overall result will be 0. So this is one property that we will be using. Other property that we use is n XORed with 0 gives the number itself. So wherever there is a 0 inside n, we will get 0, 0, and that will return 0. So we conserve our 0, and whenever there is a 1 there, XORing it with 0 will give us 1. So 1 is also conserved. So in that way we get back our answer. So if the numbers are getting repeated, what we see is that the numbers that get repeated will cancel each other and result in 0, and then that 0 XORed with the number occurring once will give that number itself. So if I say that we have our number starting from 1 XOR 2, so first of all we XOR these two numbers, then we XOR 3, then we XOR 2 again, then 1, then 4. So if we XOR each of the numbers, what we see is 1 and 1 is repeated, so these will result in 0, and then XORing any number with 0 will result in that number itself. So 1 is out of the picture, and we are left with 2 XOR 3 XOR 2 XOR 4. Now again 2 is also repeated, and that also becomes 0, and we are finally left with the number 3 XOR 4. So this is what we will get by XORing all the numbers. Now what next? So if we write 3 in binary, so we see that it is 0, 1 and 1. And what is 4 in binary? So 4 in binary is 1, 0 and 0. So if we compare these numbers, what will be their XOR? So their XOR will be 1, 1, 1, because at each position these numbers are these bits are different. So we now know that what is the first position where the numbers started to differ. So this is the index 0 itself. So now how to check, so since we have this 3:4, we first need to check the rightmost set bit in this result. So how we do this? We do that by complementing this number, by taking 2's complement of this number. So basically 1's complement of this number is 0, 0, 0, 0, and how do we calculate 2's complement? By just adding 1 here, and that makes it 0, 0, 1. So taking the 2's complement of any number will just change all the bits except the first one. So here all the numbers got inverted. So 1 1 became 0 0, except the first set bit that was here. So now this 2's complement that we have got will help us in giving the rightmost set bit. And what does it signify? The rightmost set bit tells us that the position where the two numbers differ for the first time. So here all these numbers are differing, and now we can separate our array into two parts which have a 0 with like the numbers are differing, so it will either have 1 or 0. These are the only possible combination. So what we will do is separate all the numbers having 1 at this position into one answer and 0 at that position into other answer. And since all the numbers having the 1 in that position will be twice, they will get they will become 0 because of n XOR n equal to 0, and we will be finally left with the number itself. So let's start by writing the actual code. So we will have an int result equal to 0, then we will just iterate through. So let me do it in a more easier way. I nums result shorthand operator, so result XOR result with I, and we have this now with us. So till where we have reached? We have reached till here, 3 XOR 4. Now we need to get the rightmost element. So the rightmost index is set. So for that, what we do is we just do AND operation with result and result minus 1, and finally XOR it with the result. So this will give me the rightmost set bit. So we have reached this position. Now we will have two answers, that is int a equal to 0 and b equal to also 0. So all the numbers having 0 at this position will be XORed with a, and all those numbers having 1 at that position will be XORed with b. So we will start again for int I in nums. What we will do is, if we have a 0 at that position, so how do we do it? Nums at I and rightmost. So if they both have 1 at that position, so they are common, so we are just XORing it with b. So all those numbers having 1 at this index will be XORed with b. So nums at I, and the remaining numbers will be XORed with a. So now we will have two numbers, that is 3 and 4. So our answer is an array. So vector answer is an array consisting of the two elements. So we are considering a smaller than b, and if it is greater than b, then we will just reassign our answer with b comma a. So this is coming from here that we have to return in increasing order, and finally we return our answer. So let's compile. Numbers. So what I did wrong here is I'm already taking the element, not the index, as I. So I should be here, not nums of I. Run it again. Yes, now it's fine. Let's submit it. So this gets accepted, and this was all for this solution. Hope you liked it. See you tomorrow.